Okay, in 9.0, we're going to review the Pythagorean theorem and special triangles. Okay, the Pythagorean theorem only applies and it's normally denoted with a little square in the corner to show where the right angle is. Okay, this is the formula where you normally say a squared plus b squared equals c squared. Okay, the main consideration is that c has to be the hypotenuse. The hypotenuse is the longest side, or is the side opposite the right angle. So if this is the right angle, the side opposite is over here. So if I were labeling, this would have to be C because it's the hypotenuse. Now where you put A and B does not matter. So A and B are the two legs. It doesn't matter which one's which. Okay, so let's try this. Okay, so for example 1, we're going to use the Pythagorean theorem to find the missing sides. We will leave answers in exact simplified form. Okay, so I'm going to use a squared plus b squared equals c squared. The main thing is that we get the hypotenuse correct. So right angles here. The side opposite is the hypotenuse, which is going to be my c. There's no letter on it, so I'm going to go ahead and just call it c. Okay, if that's c, then the other two sides could be a and b, and it does not matter which one's which. So I'm going to say a squared plus b squared equals c squared, and c squared is our missing side. So I'm going to leave it as c. Okay, in my calculator, I'm going to multiply these out. 81 plus 144 is 225. Okay, and then I'm going to square root both sides. Okay, let's see if it's square roots, because sometimes it comes out even and we don't know. So this actually comes out to be 15 now. Normally in algebra we say plus or minus 15. Because this is the side of a triangle, it will only be positive because we can't have a negative length. So in algebra we should think plus or minus, but since this is geometry, we're only going to include the positive. Let's look at the next one. Okay, right angles here. This is my c value across the way. It does not matter between the other two sides which one's a and which one's b. Okay, I'm going to put a letter on this side. It does not matter what letter you put. Okay, how about if I put x? Okay, so side plus side squared equals c squared. Okay, I want to solve for the x, so let's minus the 4 over. Okay, and then I'm going to square both sides. The square root of 21. See if it comes out nicely. It doesn't come out nicely. Does it simplify? No, 21 is 3 times 7, both of which are prime. So my missing side is going to be the square root of 20, no, not 27, 21. If it were 27, it would come out nicely. So I'm going to leave it with a radical on it. If I put it in a calculator, I'll get a decimal approximation. I would rather have a exact answer. Okay, I'm going to keep going. If you remember this and you want to work ahead, go ahead. Okay, right angles here. So the side opposite is the hypotenuse. That means the other two sides are the legs, and I can pick any letter I want for this side right here. I'm just going to call it x because I'm lazy. Plus 3 squared has to equal to c squared. Okay, minus the 9 over. Okay, x equals, square root of 16 is 4. It should be plus or minus 4, but again, under a triangle, it's going to be the positive value. Okay, let's look at D. Right angle, C is across from the right angle. So we're trying to find C. And you don't have to name it C, but just know that that's side C. Okay, so the two legs are the 2 and the 6. So 2 squared plus 6 squared equals whatever letter you pick squared. Okay, 4 plus 36 is just 40. Square root of 40, does that come out evenly? No. Does it simplify? It sure does. It's 4 times 10. So it's going to be 2 square root 10. If you can do it in your head, I'm fine with that. If you don't want to do it in your head, you got to make a factor tree. So maybe I go, what is it, 5 times 8? 4, 2, 2, 2. Since it's a square root, I look for 2's. 2 on the outside, and then 5 times 2 on the inside. Okay, I'm going to keep going. Okay, where's my right angle? Right angle, hypotenuse. Okay, what letter should I put over here? It's called x. Okay, x squared plus 1 squared equals 5 squared. Okay, square root of 24. It's irrational. Does it simplify? Yeah, it's 4 times 6, so square root of 4 is 2, so it's 2 square root 6. Or you're going to make a factor tree and simplify. And let's look at D. Right angle, hypotenuse. Okay, let's give this side a letter. How about just x, because we're boring. Okay, x squared plus, root 5 squared equals c squared. Okay, for root 5 squared, we can do it 2 ways. One is I would rather square it and then square root it. If I do 5 squared, I get 25, and then when I square root it, it goes back down to 5. Or you can stare at it and say, don't the square root and the squared cancel each other? And I will say, yes, they do. Okay, move the 5. Okay, square root of 4 is plus or minus 2, but we only care about the positive. Okay, G, right angle, C is across from it. Okay, so 3 squared plus 3 squared equals c squared. 9 plus 9. Okay, let's square root it. Square root of 18 is irrational. Does it simplify? It's 9 times 2, so it's 3 square root 2. Okay, let's look at H. Right angle, hypotenuse is over here. So this is C. Uh-oh. Okay, now both sides are blank. Let's give one of them a letter. Let's call it X. Okay, now these little marks mean that they're congruent. So if this is X, this is also X. So I'm gonna label them both X, and we're gonna write it, and we're gonna see what happens. So x squared plus x squared equals, 5 square root 2 squared. I'm gonna put it in parentheses so I don't accidentally forget to square part of it. If I do x squared plus x squared, I get 2x squareds equals. Okay, now I need to distribute the squared because it does cancel out this, it doesn't cancel out this. So 5 squared is 25. If I do root 2 squared, the root and the squared cancel and I just get a normal 2. So this is actually 2x squared equals 50. So, it kind of makes it better. Let's divide 2. Okay, so I get x equals plus or minus root 5, but we only care about the positive because we are in geometry land. Okay, 2 more Pythagorean theorems. Okay, right angle, hypotenuse. Okay, what letter? Should we give it x? Let's call it x again. 5 squared plus x squared equals 10 squared. So minus the 25. What's 100 minus 25? 75? Okay, square root. Okay, square root of 75. Does it come out evenly? No, it doesn't. Does it simplify? Yes, because 75 cents is 25 times 3. Square root of 25 is 5 root 3. And remember, we're only leaving off the plus minus because we are in geometry and we get positive answers. Okay, one more Pythagorean theorem. Okay, right angle, hypotenuse. Okay, what letter? Call it x. Okay, x squared plus, I'm going to put this in parentheses to make sure I square the whole thing. Okay, now I have to square both pieces. So 2 squared is 4. Root 3 squared, the root cancels with the squared, so it just gives me 3. Let me times this, 16. Okay, x squared plus 12 equals 16. Move the 12, move the 12. 4, and then I'm going to square root it. So I get x is 2. Okay, Pythagorean theorem. Okay, now on the last 4, if you were like, wait, aren't those special triangles that I remember learning? Those are the special triangles you remember learning in geometry. Okay, there's a pattern to special triangles. If you notice the pattern, you can do the problems without doing the Pythagorean theorem. So the first pattern is this one. If it's an isosceles triangle, isosceles is 2 equal sides. So these has 2 equal sides, and I can tell because it has 2 equal angles. And the pattern is these sides match, and then this one is the side times the square root of 2. So let's look back at the ones we did with the Pythagorean theorem. If I look at this one right here, these 2 sides match, so this is 3, this is 3. The third side is 3 square root 2. I just put it times it by square root 2. Okay, if I look at H, these 2 match. What did I got? I got 5. So this is 5 and 5. This is 5 square root 2. If I had noticed the pattern, I could have filled in the missing sides without showing any work. Okay, the second pattern is a 30, 60, 90 triangle. Okay, for 30, 60, 90, the hypotenuse is twice the short leg. And if the hypotenuse is twice the short leg, then the longer leg is the short leg times square root 3. And that's the last 2 problems right here. So this is the short leg's 5, the hypotenuse is twice as big. The longer leg is going to be the short side times square root 3, which is the answer we got when we did the Pythagorean theorem. Okay, let's look at J. Okay, let's see. The hypotenuse was 4, so this must have been half as big, which is how we got 2. So 2 short leg, 4 hypotenuse. 2 short leg, 2 square root 3 the medium leg. Okay, and the pattern can just help you get the answer faster. It's okay if you don't know it. Okay, let's fill in 2 triangles using this pattern. Okay, this is a 45-degree angle. Since the triangle adds up to 180, this is also 45 degrees, which means we're looking at this triangle right here. The 2 legs should be the same size. So this is 8, so this is 8. Okay, and then the hypotenuse should be whatever the sides are times square root 2. So it's going to be 8 square root 2. And I did that without Pythagorean theorem. Okay, one more. Let's try this one. This has a 30 degrees and a 90 degrees. Because triangles add up to 180, if this is 30 and this is 90, the third angle has to be 60 degrees. Okay, now according to the pattern, whatever the short leg is, I times 2 and I get the hypotenuse. The short leg is 12. If I times by 2, I get 24. Where's the hypotenuse? Here. This is 24. Okay, according to this pattern, if whatever the short leg is, the longer leg is the short leg times square root 3. So the short leg is 12. So this is going to be 12 square root 3. And if you remember the pattern, you can fill in the sides without showing work if you notice it. If not, Pythagorean theorem.